Welcome to qnawire.
Given the function f of x equals 0.5 times x minus 5 times x plus 1, well, it's going to have zeros at 5 and negative 1 based on those factors. The vertex will be exactly halfway between them at an x value of 2, and if we substitute 2 into this, we'll get 0.5 times negative 3 times 3. That's half of negative 9, or negative 4.5. So 2 negative 4.5. And there's our sketch. In your second function, you have negative 3 times x plus 1 times x minus 1. So we'd have zeros at negative 1 and positive 1 because of the factors. And then that means the axis of symmetry is x equals 0, which would be negative 3 times 1 times negative 1, or positive 3. And that'll allow us to make our sketch. 0, 3 is the maximum. In the next one, you have 4x squared minus 16x minus 9. And this is a perfect square. 2x minus 3 squared. You can tell because of the first and last terms, but if you're not sure, you can repeat it. You get 4x squared minus 6x. Actually, it's not. I take that back. So we can look to factor. Which would be what multiplies to negative 36 adds to negative 16. That would be negative 18 and 2. And so we could factor out a 4x from the first group, left with x minus, actually 2x from the first group, left with 2x minus 9. And then we can take out a 1, left with 2x minus 9. So in factored form, this is 2x minus 9 times 2x plus 1, which would mean, by the zero factor theorem, that 2x minus 9 equals 0, or 9 halves, which is 4.5, would be a 0, and 2x plus 1 equals 0, or negative 1 half. The axis will be exactly in between them. There are 5 units between them. So 2 is actually, 5 units. Half of that would be 2.5 on each side. So 2, x equals 2 is the x coordinate of the axis. So if we substitute 2, we'll get 4 minus 9 and 4 plus 1, which is negative 25, which is going to be way off my graph here. But it will be at 2, negative 25. We'll just guesstimate here. And the last one that you have to consider is negative 2x squared. I'll do it below it to give myself plenty of space. Minus 8x plus 5. And you can check what multiplies to negative 10, adds to negative 8. There isn't anything that does that. So can't quite determine the zeros, but we can find, like, you can't nicely. We can use the quadratic formula to do it, but you can find the vertex using opposite b over 2a, which is -2, and so then you find f of -2, which would be -2 times -2 squared, which is 4, minus 8 times -2 plus 5, or -8 plus 16 plus 5, which is 13. So -213, also not on my graph. Oop, -213. Estimate it to be here, and that will be an upside down parabola. We'll estimate the zeros using the quadratic formula, which is opposite b plus or minus the square root of b squared minus 4ac over 2a. So it'd be 8 plus or minus the square root of 64 plus 40, or 104. All over -4. So the square root of 104 is, oh gosh, a little bit over 10. We'll say 10.2. So it'd be 8 plus 10.2 over -4, and 8 minus 10.2 over -4. Well, 8 plus 10.2 is 18.2, divided by -4 would be negative about 4.6. And 8 minus 10.2 is -2.2, divided by -4 is about 0.6. So you can just estimate those on your sketch to help guide your parabola. Hope that was helpful.